Alright, so next let's do this question, guys. So what this question says is you are given an balloons indexed from 0 to n minus 1, and each balloon is painted with a number on it represented by an array nums, and you are asked to burst all the balloons, right? Alright. And now you are let's say each balloon is painted. You have n balloons indexed from this to this, and each balloon is painted with a number on it. Okay. On it represented by an array of nums. You are asked to burst all the balloons. If you burst ith balloon, you will get n minus 1 into this cone. If I minus 1 goes out of bounds, array it is okay, one painted on it. Return the maximum coin you can collect bursting the balloons. Okay. So let's take this example and try to solve this, right? Alright. Okay. Let's say this is a this is an example here, and we can burst like there we have 3 painted balloon, we have 1, 5, 8. Okay, if we burst this, right, so with the definition of the problem, we get how many coins? 3 into this into here we can assume 1, so 1 into 1 is 3 coins. And if we then burst this, we how many get? Because this is already busted, so 1 into 1 into 5 is equal to 5. Then we burst this is 1 into 5 into 8, which is 40, and then we burst this 1, 8. So it's a total of 56 coins we can collect. Are these maximum? Let's see. We have this, let's say we burst 1 first, right? So it goes like 3 into 1 into 5, 50. Then we burst 3 first, right? It goes like 3 into 5 into 1, then again 15, and we burst then 5, then 1 into 5 into 8, which is 40. Now it is like 70 coins, right? Things like that. Okay, so we have to find the correct maximum one. So which coin we burst first? So so there is a problem here, guys, because if let's say if I am bursting this, right? Okay, 1, 3, 1, 5, 8, like this. If I am bursting 1, right? Now I can get 3, 1 into 5 like this coins. Now 1 is not available. Then if I try to burst this, right? And I divide this problem into these two parts, right? But when I try to burst this, I need to keep track of this, right? So I cannot divide this problem, right? So that's why instead of this is not independent now. So for making this independent, what I can do? Let's take this example only. 3, 1, 5, 8, right? 3, 1, 5, 8. What I do? Let's say I go from last balloon to first balloon. Let's say last balloon I busted was 8, right? 8 busted. How much I got? Let's say because for last it is like this. This is 8 cone, right? And let's say before that, right? Before 8 I busted 1, right? So 1 is there and 8 is there. So before 8 to bust 1 before 8 I need 8 and 1 at least, right? And all of them, because before this is 8 was the last and before that 1, so only these coins are available right there. So I assume 1 here and 1 into 1 is equal to 8 again, right? And before this 1, let's say I assume I busted 5, right? So 1 5 8 must be there, right? So 5, so it goes like 40, and before that I busted 3, all of them must be there. This is 3 19, it is like 59 coins, right? So I can like how it is independent, how it's independent. It is independent, guys, because see, because last coin is 8, right? And this is 1 and 1 is 2. This 1 and 8 is not dependent on 3 and 5 at all, right? This 1 5 8 is not dependent on 3. Okay, so this is how we can approach this problem. Alright, so bottom up. So what we can do, guys, is let's try this 1 3 5 8. This is like that, 3 1 5 8, right? So let's say I am at this. The last balloon was this, right? So go like this. Last balloon was 3. So cost is 3 1 cross 3 cross 1. Now, okay, and let's say I now second last. What is second last coin for this? Let's say second last coin is 1. Okay, second last coin is 1. So 3 cross 1 into 1 is like that. Okay, okay, and but let's say I miss this. Second last coin is 5, right? So 3 into 5 into 1 like this. Okay, I have 3 and 5 now. Okay, okay, I got this 3 and 5, right? Then what? Then the third coin. What is the third coin? Third coin can be 1 and 8, something like that. How can I keep track of, like, okay, which coin is already busted and which coin is not busted already? I need to keep track of that also, right? Okay. So okay, guys, how can I do this? I am confused right now, seriously, because 3, 5 and 8 like this. Okay, let me try this again, right? 3, 1, 5 8, right? 3, 1, 5 8. Okay, let's say I open like this. I am treating this as my last balloon, right? Last balloon. So it gives me 1 into 3 into 1. Alright. So then again, I plus f of, let's say this is a function, I plus 1, right? Alright, and what? Okay, I plus 1, comma, this 1, 5, 8, it's given right there, because I plus 1 defines 1 plus 8, right? F of I plus 1, okay. Then what? Am I 1, 3, and F8 like this? So 1, 5, 8 is here. And should I need to keep the count like, okay, which element I am looking, right? Let's say I am looking second element. Okay, and plus I is here, right? One index is here, 1. So I becomes here. So if I, it is giving like, okay, like this. If I minus 1 available, okay, if I minus 1 is available here, then it will go, else it will take. Okay, so if I am, if this is taking this element, right? This element, I am assuming here and here, third value, and but it's taking this 1. Okay, if it's taking this 1 as its second element, right? Then what it can do? It goes for its I minus 1 and j plus 1 like this, right? But it's not in the present build, right? So we go for 1 only. Alright, and how do we know that, okay, it's already there and it's not already there, right? Right. Okay, so it goes for like this, from here I to n, right? If it is second, if it is L second, if it is second. Alright. But I am little confused, guys, because approach is this, but how to code it in a manner that right? So how we get the balloon burst?
So before starting the video, I'd love to tell you that I'll be taking a session on career guidance, which will be an interactive session on this Saturday at 10 p.m.
Is 5. After that, I'll ask who's the other guy. It'll say this. Let's realize
Let's take this example only and understand. Okay, 3158. So 3158. Okay, before this, if 8 next counter, so he exists over here, since you're going in the opposite, you are the two sub problems which you can, the sub problems will be in +1. This is the coin that you will get if this guy is bursted right at the end, and this is a sub problem that has to be solved. So you will say, can you please solve the sub problem from here to here, which is I comma index -1, because if this is index -1, and if this is index +1 to j. So these are the two sub problems which you can easily solve. Now, are these sub problems independent is my question. Are these sub problems independent?
Oh, guys, come on. We could have done that, right? Because let's say 3158, right? It was 3, 1, 5 and 8. And this is 1 and 1 here, right? So I element is here and j is here. Now from index could be from I to j, right? So index could be from I to j. If it is at I is at like 5, right? We are storing like 5 into 1 into 1, like last index, j plus 1, which is 1, mid and mid or index we can say, and this is alright, I is greater than j, then we are alright. Let's code this, guys. It's very easy. It has become very easy now. Alright, int n is nums dot size, right? Now what we can do, guys, is we can insert one nums dot push back 1 at the end, and dot insert at nums dot begin. We have to write like this, and okay, then okay, and n is nums dot size. After this, or okay, we can have this like this, okay, and we have this function called f, which will go with nums comma I, which is 1, and n minus 1 is the j, right? Okay, and what is the function? Function is private int f. It will take a vector of integer and nums, and int I and int j is there, right? If I is greater than j, return 0 in that case, right? Alright, and after that, what we can do, we can have this for loop, int I, int index is equal to I, index is less than j or j to j, right? And index plus plus like this, Okay, and we can have this maximum we have, right? We have to find the maximum. Int maxi is we can say 0, and okay, and then after int cost is equal to whatever the index is, we can partition on that, right? Which is nums I minus 1 into nums I dx, which is I dx actually. Okay, it's I minus 1, okay, I minus 1 I dx into nums j plus 1 right there, and after that index plus f of I will be left is there, right? Nums comma I will be same as index, and j will be here for I index minus 1, right? Okay, plus f of nums comma idx plus 1 comma j only, and maxi equal to max of maxi comma cost right here, and after all that return maxi here, and this we can return this only like this. And yeah, let's check if it passes the cases. Okay, wrong answer. Why it's wrong? 159 and it's 167. All right. Why it is so? Okay. Is this less than 0 or what? Let's check. Okay. Oh, so it's at least going to the limit. Of this what happened? Let's ask this to the guru, or we can say to this guru, right?
Independent is my question. Obviously they are independent. Yes, they are independent. Into one will exist B2 B or for B6 I'm just dependent B2 B or B4 in the second last step, or it can be B3 B4 in the second last step, or B4 B5, or B4 B6. It can be either this or this or this or this or this, anyone. For B1, this is how we need to solve. Can I say this guy can be your last guy, or this guy can be your sub problem? You will solve it. Right of range, the number itself whom we are assuming to burst. So can I say this will be the cost for every index? If we decide to burst this will be the cost. If we decide to burst this will be the cost. If we will decide to burst this will be the cost. So for every time the for loop runs, first time I'll be mini equal to minimum of mini and comma cost is what I can simply do. Once I've done this, the for loop ends, and can I return the mini? I can definitely, there will definitely be an overlapping sub problem. So -1 and plunge that in over here and return dp of. So in the function we are We know mini will be, or rather we need maxi, so maxi will be int mini, int mean rather, for int I, index equal to I goes till j, index plus plus, perfect. What will be the cost? The cost will be a of I minus 1 into a of index maxi, and I think it should be good to go. So yeah, that is a simple code, and if you write this, you'll see that you're getting all the corrected answer. But this is a recursive code which will be exponential in nature. So just make sure you have.
Okay, so I have to give it as n, right? Not n minus 1. Let's check. Yeah, now it's running. Let's try to submit it. And if it is recursion, it will give us TLE. Right? Yeah, and let's convert it to DP right here. From which value to ing can go? 1 to n, right? Which is n, size of n. So let's try to vector, right, vector of integer dp of n comma vector of integer for n comma minus 1, like this directly, right? And take this dp as it is, like this, and pass it here also, and pass it here also. As reference we can take it, right? Alright, and after all of this, let's say after this, if dp of I comma j is equal to not equal to minus 1, return dp of I comma j, right? Else return dp of I comma j is equal to like this, and pass dp here also, dp, and here also, right? Because it is going to n plus 1, so I think it will give us a runtime error. Let me check this. After runtime error, yes, because I have to take this as n plus 1 here. I am checking, and n plus 1 here like this. Layout check. I think it should work. Yeah. Okay, this will now work. How can I turn it into tabulation? I can turn it into tabulation like this only. Let's check int. There are two variables, right? So for int I is equal to 1 to I is less than is equal to n I plus plus, right? For int because j is always greater than I, right? So j is equal to I, so j is less than is equal to n, right? So j should be always greater than I, right? J plus plus. Then after that we have this logic. Take this logic here. Okay, take this logic here and put it here in this loop. For index I is equal to j to this, and f becomes dp here, right? Dp of I comma I dx minus 1, like this, and take this off, and it will become dp of I dx plus 1 comma j, right? Take this out also. Maxi is equal to return here. Maxi is equal to like this, and Alright, so because it's uh, what we can say, tabulation, so we have to reverse this, right? I is equal to n to I greater than equal to 1, right? And I minus minus, and j was like from j was okay, so j was from j was decreasing, right? So j was from j to n 1, so j now increase I to n like this only, and we will initialize dp of vector of int dp of how much time, because what is that, n we have, after n we have included two elements, right? So n plus 2 are there, this much elements are there, right? So I think n plus 2 will go here, n plus 2 comma vector of int of n plus 2 comma 0 of for edge cases, right? And what will we return after all? We return dp of 1 to n, right? Yeah, I think so. It's working, guys. Let's check. It's now working smoothly, and yeah, and let's it's done, guys, right? Okay, wait. You can close tab, guys. It's not a joke. Okay, it's all right. Whatever it is, just right. So we are here. I have already done this question, guys. Like, which one? I think partition DP balloon 1. And now we have this question, guys. Evaluate balloon expression to true. This is very hectic question. I will do it a little bit later, and before that I will do this. Okay, let's now given a string S, partition S such that every substring of partition is a palindrome. Okay, so let's take this question and move to this. Control C here. What is the question saying, guys? This is the question, right? Just a minute. I will do. All right. So this is the question, right? So you have a given a string and partition this string such that substring of partition is a palindrome. Okay. So let's say this is a string we have a B. We can partition here. All of these partition are palindrome, right? So return the minimum number of palindrome partition we need. Okay, so this A and we can partition here. We can partition here. Both of them are palindrome, right? So this is the minimum number, such that. So we have to find the minimum number of cuts we need to do. So how can we do? Let's say we go from here, and here. We partition here, and here, right? Is this palindrome? Yes. We can move forward. This 1 plus f of AB, like that, right? So AB, can we make partition here? Is this palindrome? A palindrome? Yes. So I can make partition here and then B, like that. Else 1 plus f of AB is this, right? This is 1. So 1 plus 1 is 2. This is giving me 2 partitions. Now after that, if I go for okay, I am not partition here, I am I want partition. Is this yes? Okay, let me code this for you guys. I notice what it is doing, and string s, right? Int n is equal to s dot size. Okay, we have this function f which is passing s, alright, comma I index, which is 0, alright, and this will take this. Okay, int f string, it will take string as s and 0 at index. Alright, now so let's go with 1, right? Go with 1, or let's go with 0 only. Okay. So I have a string which is temp. Let's say string temp is empty string right now, right? And I add temp, alright, I add into temp like this. F for this temp, right? Temp plus equal to what do we say? Let I have this formula for int j is equal to I, j is less than equal to n, j plus plus, like this, less than n. Okay, alright, and less than n, right? And what I can say, temp, right? Temp plus equal to s of I, s of j we can say, because I is 0, right? This first element is added in this. So temp is a now, right? So if it is palindrome, if palindrome, right? Palindrome, temp is palindrome, right? Then what we can do? We can go for if it is palindrome, then we can make a cut here, right? Then int cuts is equal to 1 plus f of s comma j plus 1, right? Like that. And what I need to find this, minimum cuts is equal to min of mini comma cuts, right, like that. Okay, and after all of this I will return the mini, right, return mini. Here mini is int x, right, and return. Just check this if it is passing the test or not. Okay, undeclared end. Alright, let's say s dot size, right, like this. Is palindrome is undefined. Okay, let's define this. Private. Okay, bool is a palindrome is a function, right? Palindrome is a function. Is string s, like this. Int n is equal to s dot size. Int I is equal to 0. And integer is equal to n minus 1. Okay, while I is greater than less than j. Okay, or equal to j, right, or we can say less than j only. If s of I equal to s of j, then continue. No. Okay, then I plus j minus, and like this. As return false. After this return true. Okay, there is an error, runtime error, something overflow. Integer overflow, why? What the hell? One plus what? 2 1. Who is saying to you this? Let me ask this to the Guruji of our Guruji. Give me correct recursive. You are entering domain of string artisan in second and bug 1 as the trap string as I. What happened when I reaches end of the string equal to size for loop turn mini remains into max and return into max and previous timeline. Okay, it goes okay. So I am not returning anything. Okay. Alright, bug 2 overcutting. You are safe cutting a log cookie for calculation mistake pieces. Okay, already. Okay, how many cuts did you make? 2. Mathematical formula cut for every single piece. And very last we will take mathematical cutting a number of pieces, not the number of cuts. Okay, -1. Bug 3 string clone trap. Side or loop. To dynamically allocate a new string temp and append character one by one. String side. Alright, what is? So first of this, if this is correct, right? Return row and I return 0 into max. Alright, j is equal to y is inside 0 this way. Row S I J. What? Okay, I can give it like this. Okay, cost 1. Oh, but first of all, I need to do this. This is okay. Okay. If I is equal to s dot size return 0 in this case, right? Okay, let me see. Okay, I think one more, 2, 1 like this. Okay, I need to return it for this -1. Alright, now it's working. It will give us TLE, so just move it to DP. Right. Alright, what is the DP for this, guys? I is going from 0 to n, so n size and vector of int, right? I only one variable is changing in this, right? Yeah, I think so. I changing. J is also there. For example, there are 2 variables, right? I and j, and do we need 2D DP for this? 0, 1 variable is here. That one is I is there, colon row, only 1 is returning to us. Okay, so only one DP will work, I think. DP of n comma -1 here, right? So take this DP from here like this and pass here. Take this DP here like this as a reference also. Okay, if DP of I is not equal to -1, right? What the hell is it? Not equal to -1. Return DP of I, else all of this DP of I equal to this, right, and pass DP here also, guys. That's it. Go for this. It's working. Let's check. Alright, now let's turn it to tabulation method, right, like this, because we are working with 0 to I is going from 0 to n, we will go from n to 0. So for n I equal to n, I equal to 0, I minus, and then j will be what? J will be I to n, right? J was going from where to where? J was going from I to size. Then now it will go to from size to I, right? Because J should be greater than I. Is this the case? Yeah. For J is equal to n, J is greater than I. J minus also, right, and minus 1 here I think, and let's bring this logic from here. Okay, bring the whole logic from here. See here, J is only inside here only, so J is equal to I like this. This is the logic here, guys. And let's take this temp also, temp and 20 and temp. Alright, so here take all of this like this. Alright, this palindrome is only there. Okay, so temp plus J is like this. Okay, okay, then we go for dp of j plus 1 only, right? Okay, like this. Many cut dp of turn out when it's done here, dp of I many, and yeah, I think we have to vector of int dp of n plus 1, guys, because and 0 in that case because it's going far, and return dp of n I think, right? Let's check. Only okay, so it should be minus 1 or what? All of them are wrong now. Minus 1, okay. Minus 1, minus 1. Alright. Alright, dp of n minus 1 or what? Are you saying this? N minus 1 minus 1. Alright, let's see what happened. Let's for that, let's go to here. What is the problem? Okay, let me check first. Are we good? Okay. And greater than 0 and minus 1. Okay. Equal to right minus 1. Are we good? I don't know. Let's go to Gurdev. This will be a small little bug. I don't know what it is. Okay, let me show you. See. Okay. We're going to wait. Okay. You successfully mapped the advantage in bottom-up tabulation. You correctly recognize the recursive function I only depends on the j plus 1. Its evaluation must be equal to 0. Okay, however, Tasman has fallen into out of bound trap and then x foreground temporal product x is wrong in the real world. You built a DPI backward physically present. Okay. Manually resetting at g to 0. Alright, so I should return dp0 and okay, I'm just going to n minus 1 to I. Okay, it's good. Many, okay. Okay, I can give ij also. Okay, alright. J is equal to I, j is less than n, g plus plus dp of n plus 1 comma 0 and dpi dp0 minus 1. Let me do this. N plus 1 is difference to be minus 1 temp. Let me do this now and less than intercept, or we can say n, right, palindrome tp I comma j is palindrome and I comma into j, right, subject, right, dp of 0, right, and minus 1. Let's try this now. Alright, enter here. Okay. What? Palindrome comma j. Yes. Alright. Whatever. Yeah. Alright guys. It's good. Thank you so much for watching it, and I'll meet you in the next video.